In the intricate tapestry of the cosmos, mass stands as a fundamental property of matter. Simply put, mass is a measure of how much matter an object contains. It dictates how heavy an object feels, and its resistance to changes in motion. Imagine pushing a shopping cart filled with groceries versus an empty one. The difference in effort highlights the concept of mass. Newton's second law of motion states that the force acting on an object is equal to its mass multiplied by its acceleration. This means that a more massive object will accelerate less than a less massive object when subjected to the same force. Mass also governs the gravitational attraction between objects, as described by Newton's law of universal gravitation. The more massive an object, the stronger its gravitational pull. The concept of mass is central to our understanding of the universe, from the motion of planets to the behavior of galaxies. While the concept of mass is well established, the notion of negative mass introduces a mind-boggling paradox. Imagine a hypothetical substance that possesses negative mass. This peculiar concept, while seemingly absurd, emerges from certain theoretical frameworks. Negative mass, if it exists, would exhibit some truly bizarre properties. For instance, if you were to push an object with negative mass, it would accelerate in the opposite direction. Furthermore, the gravitational interaction of negative mass with positive mass would be equally perplexing. Instead of attracting each other, objects with negative and positive mass would repel each other. The existence of negative mass, while highly speculative, has not been definitively ruled out by our current understanding of physics. It remains a tantalizing possibility that could revolutionize our understanding of the universe. Newton's law of universal gravitation describes the attractive force between objects with mass. However, when we introduce the concept of negative mass, the results are astonishing. According to Newton's law, the force between two objects is directly proportional to the product of their masses. If one of the masses is negative, the resulting force would be negative, implying a repulsive force. Imagine two objects, one with positive mass and the other with negative mass, placed at a distance from each other. Instead of attracting each other, they would experience a repulsive force pushing them apart. This bizarre interaction has profound implications for our understanding of gravity. If negative mass exists, it would violate the weak equivalence principle, a cornerstone of Einstein's theory of general relativity. The presence of negative mass would necessitate a re-evaluation of our fundamental understanding of gravity. However, until we have concrete experimental evidence, the implications of negative mass on Newton's law remain speculative. Section 4. Einstein's relativity and negative mass wormholes and warp drives. Einstein's theory of general relativity revolutionized our understanding of gravity, describing it as a curvature of space-time. This theory has profound implications for the existence and behavior of negative mass, leading to possibilities like wormholes and warp drives. Wormholes, hypothetical tunnels connecting different points in space-time, have captured the imagination of science fiction enthusiasts. According to general relativity, exotic matter with negative mass energy density could potentially stabilize a wormhole. Warp drives offer the tantalizing possibility of faster-than-light travel by warping spacetime itself. By compressing spacetime in front of a spacecraft and expanding it behind, a warp drive could theoretically allow faster travel. However, both wormholes and warp drives remain highly speculative concepts. The existence of negative mass energy density, crucial for both, has yet to be confirmed experimentally. Section 5. The search for negative mass experiments and theoretical frameworks. The search for negative mass has been a subject of great interest within the scientific community. While no conclusive evidence has been found, several experiments and theoretical frameworks suggest it might be more than just a theoretical curiosity. One avenue involves the study of exotic matter such as particles with negative mass energy density. These hypothetical particles could potentially be created in high-energy particle accelerators. Another promising area of research focuses on the Casimir effect, a quantum mechanical phenomenon. Some models suggest that by modifying the geometry or material properties of the plates, it might be possible to create regions of negative energy density. While the experimental search continues, theoretical physicists are exploring its implications in various cosmological and astrophysical contexts. Section 6. Future implications, revolutionizing space travel and beyond. The discovery of negative mass could revolutionize various technological fields, particularly space travel. One of the most tantalizing prospects is the possibility of constructing warp drives enabling faster-than-light travel. By manipulating space-time, warp drives could allow us to reach distant stars and galaxies within human lifetimes. Negative mass could also pave the way for the creation of wormholes, shortcuts through space-time. Beyond space travel, negative mass could have applications in energy production and other technological fields. It could be used to create exotic materials with unprecedented properties, leading to advancements in optics and telecommunications. Section 7. Conclusion. Unraveling the mysteries of negative mass. The concept of negative mass continues to captivate the imagination of physicists and science enthusiasts. Its existence, if confirmed, would challenge our fundamental understanding of the universe. While experimental evidence remains elusive, ongoing research suggests it is a possibility worth investigating. The search for this enigmatic substance could lead to groundbreaking discoveries that could revolutionize our understanding of gravity and space-time. The potential implications of negative mass are vast, from revolutionizing space travel to unlocking new sources of energy.